Hey guys, how's it going?
Hey,
You awake there, Nick?
yeah.
All right, so I was just gonna answer any questions. There's really nothing new to go over. The only thing that would be new is we do have, we are gonna take a practice test next week, which I just posted in the classroom. Make sure you do download the lockdown. I'm about to do it for my computer as soon as this is over, so I can troubleshoot any problems with it. But basically, that's how I think they're going to let you guys take secure tests online.
Did you just use your phone?
You can't, that's the only device I think you can't use is your phone.
I'm saying to like. Never mind.
Wait, so what are they making us download?
It looks like, let's see if I can go to the page. You guys can see my screen, right?
Yeah.
So it's called the Lockdown browser. And so it looks like there's different editions. The only thing I think it doesn't work with is mobile phones, but it'll work with Chromebooks, iPads, Windows or Mac. So I think it's just a how to, like, I think it just locks down your browser so you can't do anything else. So you can't like search anything else. You can't download anything. I think it's just a way to, I'm sure there's probably ways around it, but it's just their way of helping secure the test.
So it works on everything besides phones, pretty much.
Yeah. So
I
probably,
guess everybody's gonna be using their phones.
yeah, I'm not really sure how they're going to really do that. I wonder if they're going to be trying to make the test harder because of that.
Oh man.
So yeah, we still, I don't think we have, did they finally release an exact date?
No, I
Okay.
don't think so.
I haven't seen one
Did
yet.
they say it was like 2 days in like May?
Wait, are we coming back May though?
Theoretically.
Hmm. Wait, Mr. Coy, can you explain the thing to me though, like mathematically, what we were talking about?
Oh,
I'm
did
so
you?
confused. Like
Okay.
I get the directly proportional, but like with the equation, it doesn't make sense to me.
Okay. Then let's do this.
Wait, my audio's not working.
Cause like I was thinking, all right, look, so if it's like B equals R, right?
Mm-hmm.
And then I is constant, so you just cancel that out. And V equals R, and then I was like, what? That's why I never finished SDO1 because I was confused. Like, I did most of it, but like I don't know, I was just confused.
Okay. So the whole thing of why I used to tell you guys to cancel out the constant, that's not actually like exactly true. So the only time you cancel out constants is when you're doing a ratio problem. If you are not doing a ratio problem, it doesn't make a whole lot of sense to cancel it out because you're right, you can't. A ratio problem is saying that, oh, if I change this, this will also change, and by how much. If we're looking for an actual value, you have to figure out what I is so that you can plug it in. So let's say I is 2, then whatever R is, V is going to be twice as big. And so that's how the math works. Is you don't actually cancel out I. You need to know I. As far as doing SDL1, you shouldn't be calculating anything.
Really?
Yeah.
Mr. Corey.
Uh,
Mr. Corey.
Yes, Navi?
So I was yesterday I was trying to do the problem sets and I got stuck on 5.
Which
The SDO5.
oh, SDL5. As how to set it up or
Yeah, just like the predicting part too. So it was like which resistor should have the larger current through it? Would we just say like the largest resistor or would we have to specify like which resistor it is?
SDL5?
Yeah.
Okay.
Because couldn't it be like, what if resistor 2 is the biggest out of all of them? Then wouldn't the current be like different for like the different paths?
So you're asking between your two parallel circuits?
Yeah, so what if one of them is bigger than the other one?
So did I annotate that? Anyway, okay, so you're asking which resistor should have the larger current through it? So they mean
Yeah,
of the three.
yeah.
And it should be which resistor should have the smaller current through it. I gotta fix that. Anyway, so again, like I do just want you to predict. So which one do you think would have the larger current going through it?
The
Low ones.
R1.
So this one?
Yeah,
All right, why?
because it's in series, I'm guessing.
Yeah,
Wait, so that's right.
yeah, that's it.
Oh, okay. And then what about like B, larger voltage? Would we just say they all have the same? Oh, wait, never mind. Wait. I don't know. I'm getting confused between the.
Well, it very much depends which one you make the large one and which one you make the small one. So you should definitely choose your order.
Oh, so we choose them.
Yeah. Label them yourself.
Oh, that's why.
So yeah, so I can't tell you which one is going to be right until you have decided which is going to be your large, medium, and small. Because that would
Okay,
definitely change.
that's why. Because I didn't label them. I was just.
It would be really hard to predict the voltage if you didn't know which one was which.
Yeah, and then for the previous SDOs, I tried to turn them in yesterday, but then are we supposed to turn them in on Google Class, or do we just email those as late as well?
No, please turn them into Google Classroom. The late work is mostly for anything from the old classroom or anything from before we actually started using Google Classroom full time.
Oh, okay.
That's just so I can, like, I was originally going to maybe put like a open late work assignment in Classroom, but it just didn't really make sense organization wise.
Okay.
Mr. Coy?
Yes.
All right. So you know how you said parallel voltage is the same and like series current is the same.
Yes.
So like, where does that come from? Because like I took E-Tech over the summer,
Mm-hmm.
and like they never said that. That's why I'm kind of confused, or like that confuses me a lot. 'Cause,
Wait,
like
they never said that? How did you do that then?
we always use like the triangle, like V over IR, and then P
Well,
over.
I think, have you done any of the SDLs yet?
Well, if I'm being honest, I tried one, and
Mm-hmm.
then like I said, I got confused with the V equals R thing. So then I was like, whatever, and I just threw it to the side.
Okay, so what I want you to do is predict them and then actually measure them, and that's kind of the beauty of this is I don't know why they would never mention it. Probably because they just wanted you to be able to solve it, which is all good. But if you actually go through and you solve them, you'll find that everything in parallel ends up having the same voltage, and everything in series ends up having the same current. And those are just based off of Kirchhoff's loop and junction rules.
Okay.
Because current literally is how many electrons are moving. And if they're in the same wire, they're going to have the same amount of electrons going through them. You can't lose or gain electrons. Voltage is how much power each little electron has. And if these electrons started off in the same place, even though they went to different places, they should have started with the same amount of energy, which means they'll have to lose the same amount of energy before they're allowed to come back together. Electrons with different energy levels are not going to be hanging out in the same spot.
Oh, and I watched this Khan Academy video, and it had like a really good visual of like a tank of water, and
Ooh,
like
could you
showing
send it to
how.
me then?
Yeah, I can send you the link on Google Class, or I'll just send it on Remind.
Yeah.
It shows you like a good visual, so like if people are having like a hard time like understanding it, it just allows you to like get like a picture in your head.
That sounds excellent. Thanks, Navi.
Mm-hmm. No problem.
So I hope that helped answer your question a little bit, Nick. I recommend just going through it. Is someone else drawing on this?
I don't know.
Okay, because I'm not sure, because I'm pretty sure I didn't click, so that's fine. Hopefully that clears up some questions for you, Nick, but basically you just want to kind of just honestly try it. If you have problems measuring it, let me know, because that I can definitely help with better. As far as the conceptual, I feel like just keep playing around with it. If in a week, if next week you still have no idea, we'll try to rehash it again.
All right.
But I think it's just one of those things that takes a little bit of time to get into your head.
Wait, and if I have questions, you want me to text you? Like, what do you want me to text you? The remind too?
Remind is, yeah, so I'm checking my anytime I'm on my computer doing work, my remind is open.
Okay.
So that's probably the best way to reach me during the workday.
All right.
Yeah, good question. Anything from anyone else or something you guys would just want me to go over again?
Mr. Coy,
Yeah, what's up?
for the SDL5, I noticed that the question for B is different than the one you have up from the packet. For B, it says which resistor should have larger voltage across it.
Which is the correct question. I actually have to change it. Basically, it's just because I tried to copy and paste these outside to just make it easier for you guys to turn them in. So the original questions are correct. This is me. I just really quickly, I actually don't think I have those labs in a soft copy. I just have hard copies of them. So I did get them printed before. And this was me quickly trying to make a soft copy so that I could publish for you guys.
Oh.
So yeah, if you find any errors again, please let me know and I can try to go in and fix them. Like that shouldn't be measured voltage, that should just be voltage.
And so since SDL5 has both series and parallel, it could either be like both resistors that are in parallel or just the single one in series for which one has a bigger voltage, right?
Yes, absolutely, depending on how you arrange your voltage, your resistors.
Oh.
And there is a rule for it that if after you guys try it, if you're still not sure like why what happened, I'll talk about. But I do want you to try to make your predictions for yourself. And then as people start turning in the various SDLs, I'll probably have just at least one day where we go over where we go over them one by one and talk about why this happened and what happened, what's happening inside, things like that.
Okay. And actually, I'm not quite sure how to put the resistors both in parallel and series on the actual breadboard. Is it just like how we normally put them, and then how?
Let's see. Basically, if you have your breadboard and you have your, let's see, red line on this side. I'm still new to this drawing tool. And your blue line on this side. You'd want to have your resistors be basically one just goes to some random spot.
You know you can use Tinkercad. It'll have like a breadboard there.
Is that a website?
Yeah.
Okay, I'll probably do that next, but we're already here.
Right.
And then you want to take your other ones and put them in the same places. And so that way this one is in series and then these two are in parallel. Tinkercad.
Oh, okay.
So that's the way you'd want to set it up. If that's not clear, I can go and try to make it more clear in Tinkercad. So.
Well, I think it makes sense. You just have two holding hands, right? And then the other one behind it. But in like the hole right behind the one in series?
I think so, but. All right. Oops, circuits. Let's see if this works. Okay, not gonna do this right now, but basically with your breadboard, yeah, I think you're right. I really don't want to show video of myself, but here, let me go get the breadboard really quick. I look like crap, but that's okay.
No.
We all do.
Okay. So basically, this is all in parallel. So if I wanted to do one in series, all I would do is I'd pick one spot where they all hold hands. It doesn't really matter where, it could be anywhere on your breadboard. But so that would be my one in series, and then I want my other two to hold hands with it. And so the ones that are in parallel are holding hands with the same resistor and the same part of the battery. So right here, I have my one in series because it's holding one hand here, one hand here. These are in parallel because they're both holding one hand here and one hand here. So they're essentially also holding hands with each other.
Oh, okay. So it just depends where you actually place the end.
Yeah. And so you could do it either direction. It doesn't really matter. But the main thing is if they're in parallel, they're holding hands at the same spot or on the same lines. So the same line here horizontally, and then whichever the positive or negative on the vertical lines.
Oh, okay.
So this is one way to set up number 5.
You said horizontal for parallel and vertical for series?
No, so just, how do I say this? So basically the one that's in series connects somewhere and connects somewhere different, and no other resistor connects in the exact same place. Whereas for these two resistors, it's a little hard to see, but they're all, these two are in parallel because they're holding the same place here and they're holding the same place here.
Oh, okay.
So they're essentially holding hands with each other. And so they basically, parallels are their own loop.
Mm.
Whereas this one holds hands with one side of the battery and then one hand is holding the other two resistors.
Oh, okay, I see.
All right. Any additional questions you guys would like me to answer or things to go over?
Can we go over the last part of problem set 11?
Yes. Let's screen share again. It's problem set 11. Okay. So for problem set 11, oh, the last one with the Pivot Interactive.
Yeah.
So basically what you'd want to do for this one is actually go to Pivot Interactives and watch the video. So yeah, this is hopefully to start getting you guys ready for a physics fight. This is one of the questions we might do.
Wait, so was that mandatory, or was that the one that you said it was like our choice to do?
The problem set or doing a physics fight?
No, the last question on the problem set. The
Ah,
lab thing.
So doing the lab is optional. Doing the problem set is not.
No, so like I did the whole problem set. So remember the part that on the bottom it said the lab isn't. So this is a lab, right? That you're doing right now.
I'm not doing the lab, actually. So
Oh, I think I skipped that thing. I'll just finish it now.
yeah, just go ahead, finish it. If you need me to return something, let me know.
Yeah.
But basically, yeah, depending on how long this goes on, I might have to buy seats. So we'll see what happens. So let's just go look at one of them. Doesn't really matter who's. So I do want you guys to, no, I actually want to look at it. So basically with this, and so the question of this one is linear and also angular. You can do either one. But basically you want to use your tools here to watch the interaction and try to use that to determine was momentum conserved in this collision. So you can use the measurements from either the can or the wood block. I don't really care. But you want to try to figure out exactly how fast are they going at the same speeds? Does that make sense? And try to
What go the same speed?
so looking at your wooden block, so you can choose this toolbar up here. So you can try to essentially get relative speeds for this. So after your hit, so you can get each frame. And then so that's your initial momentum is this ball, or oops, went too fast. So you can get how fast the block is moving at its center and how fast this ball was moving originally. So you can get the momentum for the ball originally with how fast it's moving, and they give you the mass of it down here. And then you can look at after the hit, how fast is the ball moving horizontally? How fast is the block moving horizontally? And from there, use that to try to determine is angular momentum conserved. Or, excuse me, in this case, did I ask angular or, I forget if I asked angular or angular momentum. So for angular momentum, you're gonna wanna specifically look at not this, let's get rid of that. You wanna look at the angle of how much did your angle change? And does that make sense with the fact that this ball is applying this specific torque, and does the angular momentum of the ball change such in a way that angular momentum is conserved? And so basically I'm essentially making you do the lab without making you do the lab. And so basically, even though this ball isn't really spinning, you can kind of tell by the glare on the ball itself, it does have some angular momentum because it does have some radius and some velocity about that radius. And then as soon as the block is hit, that now has some angular momentum because it's rotating, and you can actually, measure exactly how fast it's rotating with your little angles right here. And then basically you just want to make an argument either for or against angular conservation of angular momentum in this case. Does that provide a little more feedback on how to try it?
Are we gonna have to find the velocity of it?
You can. I would probably recommend that.
We use the time that they give right there, like in the.
Yeah. So this tells you how much time in between each frames And then you can use that to determine exactly how much time has passed between each angle change, between each frame change, or distance change.
Okay.
So I guess to provide like an example, we could do the actual momentum, like is momentum itself conserved here? And so what I would do for that is I would first get the initial momentum of the ball. So I would say, okay, this is my original time, take down my original time, let it go a certain distance, so that was convenient, and then figure out how fast was it going during those 10 seconds. And then afterwards, after the hit, and now I'm going to track, well, how fast is the ball bouncing back? How fast is the center of mass of the block moving? And then from that, I can determine if momentum was conserved or not.
Mr. Coy.
Yes.
So I tried to go onto the problem set 11,
Mhm.
but it said that I need to request access to edit. Because I turned it in yesterday, because I didn't know about the.
Yeah, so that's what I mean. I have to return it to you, which
Alright.
I can do. I just got to go do it. So basically, when you turn things in, you make them my property as
Mhm.
far as Google Docs is concerned.
Mhm.
So whenever you turn something in, basically you're not allowed to edit it again until I return it to you. Just that I think that was originally done so like students couldn't edit things after the due date. But can you edit
I got it.
now?
Thank you.
Yeah, no problem. Did that help answer your question, Ashley?
Yeah.
All right, cool. Do we have any additional questions or further clarifications needed?
Mr. Coy,
Yes.
I finished my SDLs 4 and 3, but I haven't sent them to you yet. So is it better if I just send them through Remind, or should I show you now?
Oh no, go ahead, just turn them in on Google Classroom is fine.
Oh, because I just wanted to make sure that what I had was like right.
Got it. Let me actually look at my participants. Let's see. Nope, I think I have to, still not great at this.
Because I did turn them in on Google Classroom, but
Do you want me to just take a look at them now then?
yeah, if that's better.
Yeah, if they're already here, then that probably would be the easiest way to do it. So 4 and 5 or 3 and 4?
Or 3 and 4, yeah.
Okay, so for 3, makes sense. I mean, you
By
could.
the way, Mr. Coy, I sent the link in the chat.
All right, got it. Thank you. I mean, this pretty much is what you expected, right? Like your measured results were what you predicted for the most part.
Yeah.
Because if you did this, you got about this.
Oh.
Right? Like that should be pretty much what you got here. So yeah, looks good. I can go look at SDL4. Um, Where'd you get this number? Ah, I think that's, how did you get the total resistance? Oh, I see what you did. So you did 1/10 plus 1/2 equals. Okay, no, that makes sense.
I didn't realize it was on mute, but I did 1 over each resistor and then common denominator, and then added everything and did the inverse of that to get the total for the circuit.
Mm-hmm. Sorry, I actually didn't realize I wasn't screen sharing, so you couldn't see what I was looking at.
Yeah. Yeah, I had mentioned that, but I was on mute and you didn't hear me.
But yeah, overall, it looks like exactly what I expect. It looks like your battery is starting to die a little bit, which makes sense.
Yeah.
But I mean, this is actually not a bad voltage, and that's especially with whenever you connect things in parallel, you have a much higher current. As you can see here, like that's a pretty high current
Mhm.
as compared to everything you did in series, and so it'll just drain your battery. So yeah, whenever you're doing these ones that are with lots of parallels, you want to avoid leaving it on because it really drains the battery much faster than if it was in series because your resistance got lower.
Yeah, and I actually made the mistake of leaving it connected overnight, so it's probably going to be a lot lower for the following.
That's okay. If it gets so weird that you start getting varying voltages or currents, then that might be when you might need a new one.
Oh, okay.
But as long as you're getting like constant data, like it's not changing all the time, then it should be okay. Once it hits 6, it's pretty much done.
Mm,
So yeah, if you're getting like a voltage of 6 out of your battery, it's probably over.
got it. Thank you.
Yeah, no problem. Any additional questions here, guys? Maybe, no.
I don't think so.
Is there anything you guys would want me to go over again or talk about or provide extra practice for?
No, I think we're good for now.
Okay. Then I guess last reminder is I definitely highly recommend if you haven't gone and watched it, I would watch, I think they did another one today or yesterday, but the AP is releasing their own physics review videos that are pretty good. It's just basically a class reviewing it. They are doing lots of demos, which I think is good. So I recommend it, especially because I know rotational kinematics is something we generally struggle with as a class. So I highly recommend it. I don't think I'm like the best rotations teacher out there because it's not really my strong suit either. So I highly recommend watching that. Also, I am going to be assigning a practice test coming up. So that's what I'm actually doing here is I was starting how to set it up, but it has this thing. So make sure you do lockdown browser. I think if you try to open it in anything that's not the lockdown browser, it won't let you take it. So just make sure you do that. And then I'm still not entirely sure how it's going to work because I don't know how it looks to you guys because I can't make myself a student in this class. But I highly recommend when we do take it, I'm going to find a way, whether that be mildly legality, not sure of quite yet, but there are going to be test corrections for this. Because pretty much, especially since we're not going to nearly need to go into circuits that much, we will still practice, but for the actual test, we're not really going to see any circuit problems. So it's more important that we start reviewing now, especially because I think they're going to be moving the test date up so that you guys don't lose more while you are out of class. But yeah, so I think there probably are going to be circuit questions on them. If you get them wrong, that's fine. I do want you guys to correct them for your guys' knowledge, but I'm not going to place a ton of importance on circuits this year for that reason. How much time would you guys like me to give you for this? Like the option to take it? Like, are your days busy? Or your days tend to be very free?
I don't really have a preference. Any day is fine.
Okay. Anyone else? Nah, no one really cares. Do you need like if I gave you a full day and lots of warning, would you be able to like take it sometime in the same day?
Yeah.
Okay. Then probably maybe I'll just make it for next Wednesday, because that way a lot of people, I'll be able to remind you during the Zoom meeting on Wednesday. Does that work for us?
Yeah, that's good.
Okay, cool. Then I'll probably make the announcement today, and I won't. Let's see, can I unlock this? Assessment begins next Wednesday at start anytime from 9 a.m. to 9 p.m. So that gives you guys 12 hours to take it in. All right, so I'll be assigning that. There's also going to be multiple free response, and I especially want you guys to take the time to do the free response, because the free response questions this year are all going to be online. So we want to make sure you have some practice with doing those in an online format, because it's going to be kind of weird at first. And I'm not sure how strict they're going to be with time limits this year either. So yeah, so we'll just practice to the best of our abilities.
And so our actual AP tests, Mr. Coy, is that the same date or they're gonna move it?
I think they're gonna move it. What they might do is they might have one, they might keep the normal date and then do like an advanced date. They said they were gonna come out with all that information in April, so I imagine that information should be coming out more next week. But it still seemed a little up in the air last time I checked. So yeah, so this is what we have so far. Traditional, because so all exams are going to be, so there's 2 different testing dates, and that schedule will be available next week, April 3rd. So they haven't told us exactly when things are going to happen, but they're going to be releasing, because I think they're still trying to figure out on their end how it's going to happen. So I think they're solving that first, and then they're going to release more information about how it's going to work.
Okay.
So yeah, so I think because they wanted to make sure they could do it, because most students, you've already worked most of the year on this, you might as well have the chance to take the test.
Yeah.
And for most people, they've already paid for it, so might as well. And so I'm not really sure what this is going to mean for the test, but because they said they're changing it to a 45-minute free response only exam. And so I have a feeling for the AP Physics test that what that might mean is they're just going to make it extremely hard. Because it's a lot easier to say cheat over the phone on multiple choice. You can just be like, oh, this question, what did you get? Whereas a free response question, you have to be pretty good at cheating to make sure you either get the right answer and say it in a different way. Because if you get the wrong answer and you get the same wrong answer at the same spot and you go to the same school, you can bet they're going to be searching for that extra hard this year. So I imagine what they're doing with that is those free response questions are probably going to be extremely difficult, with the idea that if you are cheating, you won't get the full right answer, and then they're going to be able to look at what parts of the wrong answer are the same. Yes, because if I was making a test that you guys had to take it home, that is what I would do. I would make it so hard that if you did cheat, it would be pretty obvious. So I can only expect that those free response questions are going to be brutal this year. So I am going to do multiple choice just to give you a lot of look at different types of questions, but we're going to start focusing on problem sets in free response. And then Rowan, if you're still on, I did talk to your mom, and so hopefully, I don't know if she replied to me, but I'll try to get that stuff to you from the classroom earlier rather than later. But I got to just make sure the class, they'll still be opening up the school next week, which may be changing. But hopefully this was helpful for you guys. If you have any other questions, please let me know. Otherwise, I'm going to stop recording this and let you guys go on the rest of your day.